Hi, my name is Anna Rowe.
And my name is Emma Long, and the concept/topic we'll be discussing is sketching graphs of polynomial functions in lesson 8.1.1.
Our objective/goal is to develop a technique for sketching the graph of a polynomial function from the equation and justify why these techniques work. The vocabulary and definitions for lessons 8.1.1. The definition of zero product property is the product of two non-zero products that equal 0. For example, x minus 2 equals 0, so x has to equal 2.
The definition of inverse function is the inverse/opposite of a function symmetrical across the y equals x line. For example, 2x minus y, the inverse of that function is y is equal to 1/2 x.
Roots. That's where the equation intersects the x-axis.
Slope is equal to the rise over run, or the steepness of the line.
X-axis. That is the horizontal line that determines the x-coordinates.
Y-axis, the vertical line that determines the y-coordinates.
Polynomial function. It's an expression that can have constants and variables, and that can be combined using addition, subtraction, multiplication, and division.
Quadratic equation is an equation used to solve for x in the equations in the form of y equals x squared plus bx plus c.
Exponent. An exponent of a number says how many times to use that number in multiplication. Example, b to the second power.
Degree is the highest power of the variable when in the polynomial is in standard form. For problem 811, we are trying to find where the graph of each function below intersects the x-axis. To do this, we'll have to set f of x equal to 0, which will mean it'll equal 0 is equal to x plus 3 squared minus 5. We'll distribute the x plus 3, which equals x squared plus 6x plus 9, and we'll bring down the minus 5. We can add these two variables together to equal 4. So we'll get x squared for the a value, 6x for the b value, and 4 for the c value. We can plug this into the quadratic equation as negative 6 plus or minus 6 squared minus 4a c all over 2a. We can simplify underneath the brackets to negative 6 plus or minus radical 36 minus 16 all over 2. This will equal negative 6 plus or minus radical 20 over 2. And since radical 20 is equal to 2 times 5, we can pull out these 2's outside of the bracket. So we can equal negative 6 plus or minus 2 radical 5 all over 2. We can simplify this by pulling a 2 out of all of these, and we'll get our final answer of negative 3 plus or minus radical 5, comma 0. And that is our final answer for part A. For part B, we'll equal f of x to 0. And since we're using the zero product property for this one, we can realize that x plus 29 equals 0, which means that x will have to equal negative 29, which will be one of our answers. Then we'll distribute x minus 74 squared. So x minus 74, which is equal to x squared minus 148x plus 5,476. We can plug this into the quadratic equation as 148 plus or minus radical negative 148 squared minus 4 times a times c, which is 5,476. We can simplify inside the brackets to equal 21,904 minus 21,904 inside the brackets. These cancel each other out, so it's equal to 148 over 2. And that will be our final answer. So 148 divided by 2 is equal to 74. So our answers are 74 and negative 29.
In problem 815, we are going to find out what are the roots of the solution when y equals 0 of each of the following polynomial functions. For problem A, we can use this polynomial function to factor. When factoring, you want to get two variables that multiply to be the c value and add to be the b value. One way to check if you have factored correctly is to refoil. As you can see, the roots of this problem are 4 and 2. Another way to find the roots of a polynomial factor is to use the quadratic formula. To use the quadratic formula, you need an a value, a b value, and a c value. Since we already have the quadratic formula, we can go ahead and plug in the values. Negative b times b squared minus 4 times a times c all over 2a. We can go ahead and simplify this down. 6 plus or minus radical negative 36 minus 36 all over 2. We can simplify this even more by saying it's 6 plus or minus 0 all over 2. And when you simplify this again, you can find that the roots are equal to 3. A third way to find the roots of a polynomial function is to graph it. To graph the roots of a polynomial function, all you have to do is look at the x-axis and see where y equals 0. On this specific graph, you can see that y equals 0 on both negative 2 and positive 2. And those are the roots.
As well as 0.
For problem 816, we are going to find what the inverse of each of the following functions is below. Since we know what the definition of an inverse is the opposite of a function, so we will basically be setting x is y and y is x. So x equals 2y minus 3. So you're just going to do the opposite on both sides. And then divide by 2. Y equals x plus 3 all over 2. And that is your inverse. For this second one, you are basically going to be doing the same thing. X minus 2 equals y minus 3 squared. To get rid of the square, you will just square root it. Add the 3. And the inverse of this function equals square root of x minus 2 plus 3.
For problem 818, we are going to match the law, equation, or formula in column 1 to its corresponding name from column 2. As you can see, the ones in column 1 are x equals negative b plus or minus radical b squared minus 4 times a times c all over 2a. As we can see, this is the quadratic formula. So we can match it over to number 4, the quadratic formula. So the answer to A is 4. B is sine of A over A is equal to sine of B over B. We often use this to try and find angles in a triangle. So we can see that B is not the area of the triangle, not the law of cosines, but the law of sines, number 5. C is c squared is equal to a squared plus b squared. That is a common formula that we all know to be Pythagorean theorem, number 3. So C is 3. D is c squared is equal to a squared plus b squared minus 2ab times cosine of c. As you can see, this cosine can indicate that it is the law of cosines. So D is number 1. And finally, E is a is equal to 1/2 a times b times sine of c. Since everything has already been used, we can already decide that it is number 2, the area of a triangle. So E is number 2.
For problem 819, we are going to consider a line with a slope of 3 and a y-intercept of 0, 2. Sketch the graph of this line. Since we know the y-intercept is at 2, we know that it must cross at 2. For the slope, we know that if it's just 3, it's going to be 3 over 1. So you're going to go up 3 over 1. You can do the same in reverse. So over 1, down 3. And then just connect the line to make your graph. B, write the equation of this line. To write the equation, we know that for a linear function, the equation equals bx plus c. Since b equals the slope and c equals the y-intercept, we can infer that y equals 3x plus 2. And that is our equation.
In problem 819 continued, Part C asks, what are the first 4 terms of the sequence t of n equals 3n minus 1? Plot these points on a new graph. As you can see, for the first 4 terms, I used 1, 2, 3, and 4 for the n values. So I'll plug in 1 for n here, as well as 2, 3, and 4. So I'll plug in 1 for 3, plug in 1 for n, multiplying it by 3, which is 3 minus 1 is 2. 2 times 3 is 6 minus 1, which is 5. 3 times 3 is 9 minus 1, which is 8. 4 times 3 is 12 minus 1, which is 11. Then I can use these points, as well as my known y-intercept to graph, and my slope to graph this new graph. I used these points 1, 2, and 2, 5 on here, and used my y-intercept and slope to graph this line. Part D asks, what are the similarities and differences between both graphs and equations? Are they continuous? They are both continuous because you can see that there are no breaks in the line. And they also both have positive slopes of 3 and 3. But one of them has a negative y-intercept of -1, while the other has a positive y-intercept of 2.